We have Melissa Paisley here today. She is our server ecosystem support and evangelist, and she's going to be talking to you about writing your first add-on.
Buenos dias. It's great to be in Barcelona with you all today. Have you ever thought, I wish Confluence or JIRA would do? You get the picture. We've all felt it. JIRA and Confluence are extremely powerful tools, but sometimes you just want them to be more tailored to you. Thanks to the Plugins 2 system, you can make JIRA and Confluence the perfect fit for your team. So what exactly is P2? The Atlassian Plugin Framework 2, also known as P2 for short, lets you build plugins to extend the functionality of Atlassian server applications. The P2 framework is a set of components for the Atlassian platform, along with the plugin framework itself, which executes the plugins and manages the available plugin modules. The list of components is quite extensive. Some of the components we'll work with today include the Atlassian REST plugin module, the Atlassian user interface, and the Universal Plugin Manager. So why would you build for server rather than cloud? Atlassian server products have a large established customer base. This provides a huge potential market for your plugin when you launch it on Atlassian's marketplace. There were nearly 30,000 active server and data center licenses in February this year, and that doesn't even include the $10 starter licenses. In addition, the Java APIs make it possible to have nearly unrestricted access to JIRA and Confluence, giving you much more freedom than you would have in Connect. Unlike cloud, there's no standard environment for JIRA and Confluence Server though. So you'll need to make sure your plugin is compatible with multiple operating systems and databases. Access, it's a double-edged sword. I'll get into this a bit more later when I talk about the Java APIs, but that is why testing is so important in the server environment. But anyway, that's why I'm here. Today, I'm going to help you work out where to start when it comes to building an add-on for Confluence and JIRA Server. I'll introduce key technologies, cover a quick demo, and provide direction on where you can find documentation and advice as you build. There'll also be some time at the end of the talk for Q&A, so if you have any questions, feel free to submit them as you go along, or Luke will be around with the mic. So, I'm going to start by talking about technologies. Before you build an add-on for the server ecosystem, you should be familiar with technologies, tools, and architecture. That'll set you up for success. So, what's an add-on anyway? A server add-on is just an OSGI bundle. That is, a jar file with 2 special OSGI entries in its manifest. It contains classes, resources, and other jars. A version 2 plugin, that's a plugin that works in the P2 framework, must also contain the plugin descriptor. This file describes the plugin to the Atlassian application framework. So now you know that, that a plugin is just a jar file with some glitter, but how do Confluence and JIRA actually load it? If you're familiar with Atlassian's products, you'll probably already have an idea about how server add-ons work, but I'm going to quickly revise the absolute basics for those who are new to these concepts. So, Confluence and JIRA Server are both Tomcat web applications. Within them is an Apache Felix OSGI container, which is where the add-on jars are dynamically deployed. It's a good idea to have an understanding of what Tomcat and Felix are and how they work, as it'll come in handy as you build, test, and deploy your add-on. That being said, Atlassian has created some tools to provide abstraction from all of this so that you can focus on the task at hand, building the add-on rather than being an expert Tomcat herder. This is where the first important tool for building add-ons comes in, the Atlassian Plugin SDK. Along with AMPs, the Atlassian Plugin SDK will help you do the herding. The Plugin SDK provides a set of shell scripts for creating, installing, and building plugins for Atlassian server products. AMPs, or the Atlassian Maven plugin suite, is built into the Plugin SDK. It defines Maven archetypes and goals specifically for creating Atlassian product plugins. I'll quickly mention a few of the really useful commands now, and later I'll use them in the demo as well to give you an idea of how they work. So here are the commands that you'll use when you create a plugin. Atlas Create JIRA plugin will create a skeleton for JIRA. An Atlas Create JIRA plugin module will prompt you to select a module type, which it will add to your existing JIRA plugin skeleton. Next, you'll want to be able to run JIRA or Confluence to test the plugin. You can run the Atlas run commands from your plugin folder, and it's going to start JIRA up with the plugin already installed. Alternatively, if you just want to run JIRA on its own, you can use Atlas Run standalone with the product JIRA switch. That's actually really useful if you just want to test out the REST APIs, because there's a REST API browser within the product, and this will let you run all sorts of different versions of both JIRA and Confluence. So I'll get into the REST API browser a little bit later. Finally, you can use the Atlas Maven package commands, which works just like Maven package. This will compile your code and package it in a jar, so Quick Reload can install the updated plugin to your running instance without you needing to restart. So, to recap, you can use the plugin SDK to generate your plugin skeleton and build some basic add-ons, or start a temporary instance of JIRA and Confluence and load and run your add-on, all without needing to know too much about Apache Tomcat, OSGI, or dependencies. I'd love to tell you that that's the last you'll hear about OSGI, but when it comes to server add-ons, in reality, as they become more complex, you'll probably need to learn a bit more about OSGI. This leads me to the next technology we'll be talking about today, Atlassian Spring Scanner. Spring Scanner is a set of libraries that make plugins faster to load and easier to develop using standard Spring or JSR 330 annotations. Previously, plugins needed to be transformed into OSGI bundles at runtime, increasing build time and reducing maintainability. Transformerless plugins differ in that the scanning and packaging required to create the OSGI bundle is completed at build time. So first, the plugin source code is scanned for special annotations. Then the information from the annotations is stored in a set of index files. Finally, at runtime, the index files are read and interpreted accordingly. This approach is really useful, but you'll need to spend a little bit of time familiarizing yourself with Spring Scanner annotations. If you want to know more, you can go to go.atlassian.com/springscanner for documentation. I'll also provide a link later on in this tutorial, which will have a copy of all my source code from the demo, and that's going to have the link in it as well in case you didn't get that down. So finally, I'd like to talk about Quick Reload. Once your application is up and running, there's no need to restart to reload your add-on changes. You just need to do an Atlas Maven package on your updated add-on, and Quick Reload will do the rest. It's much faster than shutting down and starting up the whole application each time you make a change. We used to have a product called FastDev, and Quick Reload has replaced it. So if you've got a plugin that's currently using FastDev, you will actually need to make a change to your pom.xml to switch Quick Reload to true and FastDev to false. But if you create a new add-on from scratch, it'll be enabled automatically. So Quick Reload works by watching output directories for server add-on.jar files to be created and then uploads them into the running Atlassian host application, such as JIRA or Confluence. It aims to provide the smallest possible time between a bit of code being compiled and linked to it, being loaded in the host application and then run. Now that I've introduced you to a few of the key technologies you'll be working with when building your Confluence and JIRA server add-on, let's move on to the APIs that you'll work with. So Atlassian provides APIs for Confluence and JIRA Server so that you can find the right product plugin points. Today, I'll talk about the REST APIs and also the Java APIs. The Atlassian REST APIs provide a standard interface for interacting with JIRA and Confluence. The REST APIs for JIRA and Confluence provide greater change tolerance than in-process APIs, such as Java APIs. REST APIs are also the best option for developing remote applications that access Atlassian platform services. Before starting a plugin project, it's a good idea to take a look at the REST APIs, even if you're developing a plugin that's intended to operate in process with the host application. So where can you learn more about the methods available to you via the product's REST API? The REST API browser is available within your Confluence and JIRA development environments when you start them up using the Atlassian plugin SDK. As you can see from the screen grab, you can quickly use it to review and test the available API endpoints, allowing you to review the responses you'll receive for certain values within a running application. You can also use the REST API browser to review and test REST API endpoints that you've created in your own add-on. In addition to the browser, the REST API documentation is available for different versions of the products at docs.atlassian.com. The docs provide a listing of the available public REST API endpoints, detailed description of parameters, and examples of queries and responses. So, now that you've been introduced to the REST APIs, let's move on to the Java APIs for JIRA and Confluence. These APIs are very powerful, and they'll allow you to do many things that you can't do within the REST APIs. However, with great power comes great responsibility. Allowing you the power to access so many more things sounds great, but use them without consideration, and you may make changes that result in the product being insecure or unstable. Make sure you read the documentation carefully and use only the points available and intended for public consumption. You will have access to API points that are marked as internal and experimental, and it's usually a good idea not to use them if you're creating a plugin. Internal and experimental API points can result in compatibility problems, especially when you're doing upgrades on your JIRA or Confluence instance. In addition, there might not be corresponding functions in the Atlassian Connect framework for a lot of the different Java API points. So if you're intending to build your plugin for cloud later, it might be significantly more difficult to do it if you have built your plugin server add-on to rely heavily on the Java APIs. So proceed with caution when using the Java APIs. Caroline's actually doing a really great talk tomorrow on what it took to move Confluence questions from a P2 plugin to a Connect plugin. So if you want to learn more about the difficulties and potential hazards involved there, I would recommend checking out her talk. Now, you're probably wondering how you can find out more about the Java API. Atlassian provides Java docs for its Java APIs at docs.atlassian.com for the current versions of JIRA and Confluence Server, as well as older versions. You may want to take some time to familiarize yourself with Atlassian's Java API policy. That'll help you to know what to expect when it comes to product updates and new version releases. In addition to the REST API docs, the Java docs, Atlassian provides a few other resources to help you build your add-on. So, the official developer documentation site, developer.atlassian.com, has plenty of resources, including tutorials, example add-ons, and code snippets to help you get started. When you get home, you might want to try to run through one of the many tutorials to get a feel for what you can do. If you have a question about how to use an API endpoint that's not covered in the docs, or you're looking for general help or advice when it comes to building an add-on for the Atlassian ecosystem, the developer community is a really great place to ask. The developer community is specifically focused on developers who are extending or building on top of Atlassian products. They're also a great place to network with other people developing for the Atlassian platform. Awesome, so now you've been introduced to everything you need to know to build your first server add-on. Now I'm going to run you through a demo in a few parts to provide you with, to prove just how quick and easy it is. If you'd like to run through this tutorial now with me or later in your own time, or you just want to review the source code or check out any of the resources I've mentioned in today's talk, you can go to go.atlassian.com/olabarcelona for more information. So, First, what we're going to do is to check the SDK is installed with the correct version of Java, create a plugin skeleton for the new JIRA plugin, for a new JIRA plugin, and start up JIRA with our new plugin installed. So let's go. Before we make a plugin, let's take a look at the configuration using the Atlassian version commands. So the Atlas version commands will allow you to ensure your system is configured correctly once you've installed the SDK. It lets you check the current version of the Atlassian SDK and amps that you have installed, and the correct version of Java that is, you'll need Java JDK 8. It also lets you check the Maven version, and as you can see here, you should be using the one that's included in the Atlassian SDK. So now that we've confirmed that the SDK is installed correctly, let's use it to build the plugin skeleton for our JIRA plugin. So we're going to use the Atlas create JIRA plugin command to do this. It's a wrapper for the Maven create command, which creates a project from a Maven template. The Atlas create JIRA plugin command prompts you to provide a group ID, artifact ID, version, and package name. The group ID and artifact ID correspond to the Maven identifiers of the same names. And here we're going to use Ola Barcelona for the artifact ID and com.atlascamp.demo for the group ID. The group ID identifies the logical group of artifacts associated with your project, and the artifact ID is the name of the project and the identifier for your plugin. These two IDs are actually concatenated to make your add-on key, which is a unique ID that the Atlassian framework uses to identify the add-on. The version is pretty self-explanatory. It'll default to 1.0 snapshot when you create your first plugin, and the package is the name of the Java package that will contain the plugin source. So, once we've confirmed the details entered are correct, the plugin skeleton is generated and a success message will appear. Cool, so as you can see, a directory has now been generated called Ola Barcelona. And when you open that directory, we'll find some files have been generated, including the POM, README, license, and a source directory. So now I'll open a project in IntelliJ, which gives a better view than the terminal. To open the project, click Open, and then locate the pom.xml. IntelliJ will do the rest. As you can see, the source directory includes a main directory and also a test directory. Now I'll open the POM and update the organization details to replace the defaults included with when the plugin is generated. So I'm replacing the organization name with AtlasCamp 2017, and I'm replacing the URL with www.atlassian.com, just to show you how that'll look in the final product. And so now that I've added some of the project-specific details, I'm going to use the Atlas run commands. This will start JIRA with the plugin we've just created installed. It works out that JIRA is the correct application to start based on the plugin properties. So when you run it for the first time, it's going to take a few minutes depending on your location and the speed of your internet connection. Because it'll need to download all the required dependencies, that can take anywhere from about a minute to about 5 minutes. If it's taking longer than that or you're getting errors, it's a good idea to make sure that you're not behind a firewall that's blocking it. And so because this takes a few minutes, I'm just going to skip ahead to where JIRA has started. For me, in this example, it took about 2.5 minutes. So now that it's finished, you'll see an information message displayed confirming that JIRA started successfully. I'm going to access the instance now in my browser at localhost:2990/JIRA. That's because I'm using a Mac. So you'll need to log into JIRA with the username and password, which are both admin, all in lowercase, and then you'll be prompted to go through some basic configuration. Don't worry, the project configuration gets saved, so you won't have to go through this setup every time. And as you can see, a warning message pops up about the database. This is because JIRA has been started using a built-in database, which makes developing much quicker. It's strongly recommended that you don't use the built-in database when you're when you're using this product in production, but when you're just building an add-on and wanting to check that it's going okay, it's really good. So we can safely ignore it. So I'm just going to finish off the project configuration. So as you can see, it's created a new project for us as well. You can also see we get a warning message displayed about the license expiring in 3 days. The license is automatically generated by the SDK and it lasts 3 days. Again, this is a non-production environment, so it's pretty safe to ignore this message. It's pretty unlikely that you're going to have your development environment up and running for more than 3 days, but if you do, you'll just need to restart it to get a new plugin, a new license. So you can view the plugin by clicking on the administration cog and selecting add-ons. You'll then need to select manage add-ons from the menu, and you'll need to, well, here I've searched for the add-on to bring it up more quickly. As you can see, there are 2 different add-ons that have been installed by my plugin. So one of them is the plugin itself, and the one at the bottom is actually a test plugin. And as you can see, the link and vendor name has now been updated, so it's taking us to the right page. So yeah, and you can see that the name of the resource listed there is actually matching the one in the file there. So now we're going to go to the REST API browser, which I spoke about before. So what I did was typed GG to bring that menu up from the top of the screen, and then I just searched API to bring up the REST API browser. So from the REST API browser, I can search any of the existing REST endpoints, and you can see there are tons listed here. And by clicking on them, you can get all the details of the API endpoints. You can also test them out by clicking the send button, and you can add parameters. And so as you can see there, we get the result there as well, so you have an example of what you're working with. So if you want to test your own REST endpoint, you can also uncheck the box at the top of the screen. So now I'm going to press Control-D, which will shut down the JIRA application gracefully. Wherever possible, it's a good idea to shut down gracefully to prevent causing any corruption to your application. That way the configuration will be stored for you when you next start the system up. So to recap, in part 1, I showed you how quickly you can use the Atlassian SDK to generate a plugin skeleton and start up your application with the plugin installed. I also gave you a quick demo of the REST API browser. Now we're going to build our custom REST resource within our plugin skeleton. Remember earlier when I said that the P2 framework managed plugin modules? Well, we can add a plugin module to our existing plugin quickly using the Atlas create JIRA plugin module commands. This command will provide a list of all the available plugin modules which we can build. I should note here that it is possible to add these manually, but it's a little slower and it requires a lot more detailed knowledge. So if you're new to plugin development in Server, it's a really good idea to use the API, to use the build module. So in this case, I'm going to go with 14 for the REST API module, and it's going to prompt me for some configuration information. So the class name we're going to use is Ola resource, and the command actually automatically generates the rest of the details, and we're just going to use the defaults. So after confirming the details are correct, the module's added to our plugin skeleton, and as you can see here from source tree, you can see all of the parts of our plugin have been modified. So it's modified some files, and it's actually also added some new files, including 2 new test modules. And it's also added a module of code in the Atlassian plugin descriptor file. And so that's actually going to add a new module to the plugin when you install it within your add-on. So I'm not going to spend too much time on the details here, but the source is available at go.atlassian.com/olabarcelona. And there are branches corresponding to each of the different parts of the demo. So I'm going to start JIRA up again using Atlas Run since I stopped it before. And then I'm going to skip ahead here rather than waiting for JIRA to start up. Usually the second time that you start it is a lot quicker though. Okay, so now that JIRA has started with our plugin containing our new REST plugin module, we can log in and check that it's working. So again, I'm going to go to the administration menu. Nope, I'm going to go to the REST API browser, sorry. And so, as you can see, the resource that we're looking for is /message. And it's going to give us a JSON object with the message in it, which will be hello world. So, first I need to uncheck the show only public APIs, and then I can search for the command, which is Hola Barcelona, and it should appear in the REST API browser. It usually takes a few moments to load. Okay, so all I need to do is hit send, and you'll see we've got the JSON object there with the hello world response. So that was pretty easy, right? So next, let's have a look at the add-on modules via the Manage Add-ons screen, and just have a look at how it's changed. So as you can see now, or in a moment, there are 3 modules now installed. And 2 of those modules correspond to that Hola resource that we just built. Okay, so our REST endpoint can say hello world. But let's make a little change to demonstrate quick reload. I think Hola Barcelona is more appropriate for this endpoint. So let's just pop that text in. So if we open a terminal window in IntelliJ, we can run the Atlas Maven package command straight from IntelliJ, which I find really easy. And as you'll see here, our tests have failed. That's because we generated tests automatically when we first built this module. So since we've changed the message that we're receiving from the REST endpoint, we need to fix the tests too. I forgot about that. So you can see that 2 sets of tests are created, integration tests and user tests. And specifically, they're being created for the REST module as well. So we're just going to update the tests now. Obviously, we should have done this before. Okay, and so I'm going to run the Atlas Maven package command again, and as you can see, it succeeded this time. And now you can see that the JIRA environment has detected the changes thanks to quick reload, and it's reloaded the plugin. And we can confirm that by having a look now at the REST API browser again. Okay, and there we go, Hola Barcelona now, as expected. So that was much quicker than stopping and starting JIRA, as you can see. And it meant that when we did our search for the API point through the REST API browser the second time round, that was also faster because it was all cached. All right, so we've created our plugin skeleton, and we've added our custom REST API endpoint to it. But you'll probably want to know how you can use the REST endpoint to display something interesting within JIRA. So next, we're going to display a panel within JIRA that uses a REST resource, and we'll modify the REST resource to use a simple Java API endpoint as well. Web panels are a bit more complicated than the REST API module created in the previous part of the demo. To create a REST web panel object, you need the panel module itself, as well as a template to display the panel, and we'll use JavaScript and CSS to add content dynamically. We'll also need to use a context provider, which will tie our components together and make them available to JIRA. To create the web panel, you can use Atlas Create JIRA plugin module again, and this time we're going to go with option 26, which is the web panel module. So, option 26, and Along with the usual module name, you'll need to specify where the panel is going to be displayed. There are a lot of different possible places where a web panel can be displayed within JIRA, and I've included a link in my Bitbucket repository with more information on how to find them. There's a really awesome command out there. In this case, we'll be placing it in the system admin decorator header, and you'll see exactly where this is once we start the system up. Now, so we're going to actually go into the advanced setup this time so we can specify a weight, and we're setting that to 50. And that actually just specifies how high up in priority the item will be in the header. So we're also going to add a resource, and that's the velocity template. And so we also need to specify a location that we're going to put that velocity template in. So the next thing we're asked to do is add a resource parameter. So we're not going to actually do that. We don't need to. And finally, we'll be asked to add a velocity context provider, which we do want to do. So we're asked to specify the class, which I have changed a little bit from the default, but it's fine to use the default. And I'm not going to add any special conditions. So once you've confirmed that all of those details, that you're happy with all of those details, you can confirm and it'll add those to the plugin. As you can see, it hasn't created any new files though, it's just added some data to the file. I also just want to reiterate that all of the instructions are in the Bitbucket repository README in case you have any problems. So, okay, cool. Sorry, I've just lost where I'm up to. All right, so I've just actually started JIRA, and we're up to the next slide. So before we go on, let's have a quick look at the context provider that we're about to implement in our plugin. As you can see, the main purpose is to add additional entries to the web fragment and make the fragment available within the XML. I've taken this straight from our developer documentation that's publicly available, and as you can see, it has two methods that we need to implement. I'm not going to go into a lot of detail on what I'm doing with this because you can use my plugin source as a template for building it later. It's basically going to be almost identical every single time. So now that JIRA's started back up and the plugin hasn't been enabled, as was expected. So you can see that there are 3 modules and none of them have been enabled. The reason that is because we can't find our class because we didn't create it. So let's do that now. Okay, so first I'm going to create a new package. And I'm just going to make sure that that's the same as what I specified before. So it's going to be called Web Context Providers. And then I'm creating a new class in that package, and that'll be called My Context Provider. If you forget what you specified, you can see it in the Atlassian plugin XML. And obviously, it's really important that those names match, otherwise your plugin won't work. So, rather than go through a blow-by-blow, I'm actually going to copy and paste the context provider that I created earlier, just because it takes a little bit too long for this demo. But again, the code is all available in the repository that I've linked you guys to. So, now that the context provider has been created, or it will have been in a moment, well, maybe I am going to take you through a blow-by-blow. So basically, once I've created that template, I'm going to run the package command again, and the system admin decorator header will be displayed. So let me just skip ahead a little bit to show you what I've done next. Okay, so the next thing that we need to do is use the Java component accessor to obtain some specific data from JIRA's running state so that we can access the current user's name and display that as part of the welcome message. You can see that the public API is documented on the screen now, and that's a screen grab again from our documentation site. So what we want to do is go back to the Ola Resource API endpoint and change the response message to use the component accessor to grab the current logged in user's username. So first, just because our tests are basically expecting Ola Barcelona, we're going to change the way that we're formatting this. So instead of using the get message to request the response, we're actually going to build the username in the get message using the component accessor, and then we're going to actually create a second method that will do the rest of the job for us. So as you can see, I'm using the component accessor .get JIRA authentication context .get logged in user .get display name, and that'll actually grab the information through the Java API straight away and pull it into our add-on. And so now I'm going to use that in the get response method, which I'm about to build. So the get response method is pretty straightforward. It's just going to use that username that we built, and it's going to return the JSON object like we had specified before. But this time it's going to return Ola and then the username rather than Ola Barcelona. Okay, perfect. So now I'm going to fix the tests. So what I'm going to do is I'm just going to build a test username. So we're just going to say string user is test user. And then we're going to call the get response method instead of the get message method. Okay, so now we've done that, everything should be right, and we should be able to run our build again. Oh, sorry, I forgot. We need to change it here, obviously, as well, to reflect that we're expecting the user. Okay, so now we're going to run our package, and all of our tests should pass. Awesome, and as you can see, Quick Reload is doing its job again, which is the best. If any of you have ever used fast dev before, you'll know that Quick Reload is so much faster. And so now if we go back to our site, and log in. So the reason I'm having to do this is because I actually cleared my plugin directory using a Maven clean before I did this last part of the tutorial because I made some errors and I actually wanted to repull it from GitHub. From the Git repository, just to explain. So now if we go into the add-ons menu, it'll take us to administration, and that was actually the wrong slide again. I'm sorry, guys. I'm having a bit of a technical error here. I'm just waiting for it to fast forward because I do really want to show you how it looks right at the end. I'm just going to fast forward a little bit, but it's still a little bit slow. I'm sorry. Sorry for the wait, everyone. Okay, so I've run the package again, and now we'll go back into the product after the quick reload runs, and hopefully this time we'll actually see the changes. Sorry, I think this might actually be the wrong video again. So, I don't have any, I'm just going to skip ahead to the end of the deck. I'm really sorry, guys, but if you do run the code in the Bitbucket repository, you will see where in the admin decorator header it is. But yeah, as you can see, in only about 25 minutes, I was able to create a new plugin skeleton and run it in JIRA and the REST module. And create a REST module, and a web API module to modify JIRA. So let's do a quick recap. Understanding underlying frameworks and tools is the key to success. Using Atlassian's API documentation will help you find the right product plugin points and the Atlassian SDK makes building a server add-on quick and easy. I hope this talk helps you to understand the components of our server ecosystem and just how quick and easy it is to customize Atlassian server products to meet your needs or the needs of your customers. In conclusion, whether it's to simplify your job as a JIRA administrator or to make big bucks in the marketplace, customizations can have a huge impact. When you get home, I hope you can all start building an add-on for an Atlassian product. So, now, thanks for listening, and we've got some time for some Q&A.